Here we are seeing problem based on finding the sample size small n, right? So first problem, the average value of x of a random sample of observation from a certain population is normally distributed with mean 20 and standard deviation 5 by root n. How large the sample should be drawn? In order to have probability of at least 0.90, that x bar will lie between 18 and 22, right? So given that the probability of at least, right, 0.90, that x bar lies between 18 and 22, that is in notation. So x bar lies between 18 to 22, so we need the probability. So probability of 18 less than x bar less than 22 is at least 90, so minimum 90, so 0.90. so I am taking equality, so equal to 0.90. so maximum it can be anything, right, less than or equal to, so I am taking equality, right? So x bar sample mu, sample mean, mu population mean, sigma population standard deviation. Given population mean mu is equal to 20, right, normally distributed population, right, 20, and its standard deviation is 5 by root n, sigma is equal to 5 by root n. So probability of 18 less than x bar less than 22 equal to 0.90, subtracting mu on each inequality and divided by the sigma, right, standard deviation. So probability of 18 minus mu by the standard deviation 5 by root n. So x bar minus mu by standard deviation 5 by root n less than 22 minus mu by 5 by root n, which is equal to 0.90. We know z is equal to test statistics x bar minus mu by standard deviation. So that is z. So in the middle of the inequality we are replacing x bar minus mu by standard deviation, that is 5 by root n by z, right? So it becomes probability of 18 minus 20 by 5 by root n less than z less than 22 minus 20 by 5 by root n, which is equal to 0.90. So that implies probability of minus 2 by 5 into root n, because 5 by root n can be written as root n, right, because it is in the denominator, so it's reciprocal root n by 5. So 18 minus 20 minus 2, minus 2 by 5 root n less than z less than 2 by 5 root n, which is equal to 0.90. So now we can split this area. This is the area, right, probability of, this is normal curve also, right? So minus to plus, when you are going in the area between minus a to plus a, in between 0 is there. So we are dividing the area, first negative part, then positive part. Negative part means minus a to 0 and plus the positive part means 0 to a. Similarly here minus 2 by n root n to 0, then 0 to 2 by root n, right? But the negative area, suppose if you are having the negative area minus a to 0, then that area is equal to the same positive area, positive side area, right? Both are same because area is always positive, we know, but the area, total area minus a to 0 is equal to 0 to a, because normal curve is symmetric. If you are taking both side of z is equal to 0 line, both sides are symmetric, same, that is there is no change in that area. So whatever, if you are taking the negative side area, it is equal to positive side area. So if you are having minus area between minus 2 by 5 root n to 0 is nothing but the area between 0 to 2 by 5 root n. So therefore, so you are having 2 times probability of 0 less than z less than 2 by 5 root n, which is equal to 0.90. So probability of 0 less than z less than 2 by 5 root n, which is equal to 0.90 by 2, that is equal to 0.45. So from the table you can immediately take the value against 0.45. You are having 1.65. So 2 divided by 5 root 10, which is equal to 1.65. Therefore root 10, which is equal to 1.65, then reciprocal of 2 by 5, that is 5 by 2. So you will get 4.125. Therefore n is equal to, squaring both sides, 4.125 the whole square, which is equal to 17.015, approximately 17. So size of the sample is 70. Next problem. From a population of 169 units, it is desired to choose a simple random sample of size n if the population standard deviation is 2. Population standard deviation sigma, right, equal to 2. Determine the smallest n for which the probability that the sample mean differs from the population mean. Sample mean x bar differs from the population mean mu, x bar minus mu, right, difference. You are taking modulus. More than 0.95 is controlled at 0.05, right, 5%. So given that the probability of the sample difference between more and population mean, right, so mean of difference between sample and population mean by more than 0.95 is controlled at 0.05. That means probability of modulus x bar minus mu, that is the difference between sample and population, more than 0. That is greater than 0.95, that is the probability is controlled by 5%, that is 0.05. That is what they have given, right. So given population standard deviation sigma is equal to 2. So probability of modulus x bar minus mu greater than 0.75, which is equal to 0.05. So greater than, if you are having probability of x greater than a, can be written as 1 minus probability of x less than a. That is the idea. We are using the same idea. So x modulus x bar minus mu greater than 0.75 can be written as 1 minus probability of modulus x bar minus mu less than or equal to 0.75. That is equal to 0.05. So probability of x bar minus mu less than or equal to 0.75, which is equal to taking that 0.5 to your left hand side, and probability of x bar minus mu less than or equal to 0.75 to the right hand side. So you will get probability of x bar modulus x bar minus mu less than or equal to 0.75, which is equal to 1 minus 0.05, that is equal to 0.95. So we know modulus of x less than a means x lies between minus a to plus a. We are using that idea. So probability of minus 0.75 less than or equal to x bar minus mu less than or equal to 0.75, which is equal to 0.95. So same area lies between minus to plus normal curve, right. So we need a normal curve, that is we are making the center point in the inequality as z. So if you need z, then divided by the standard deviation, right. So probability of minus 0.75 by sigma by root n, right, less than or equal to x bar minus mu by sigma by root n less than or equal to 0.75 by sigma by root n, which is equal to 0.95. So the center become z, right, sigma equal to 2, substituting that value also. So again you are having the normal curve area, right. Probability of minus 0.75 by 2 root n less than or equal to z less than or equal to 0.75 by 2 root n, which is equal to 0.95. This is the normal area between minus 0.75 by 2 into root n, because you can write it as a reciprocal, and up to the area covers 0.75 by 2 into root n. So minus value to plus value, so you can split it into 2. So this can be written as, so probability of minus 0.75 root n by 2 less than or equal to z less than or equal to 0 plus probability of 0 less than or equal to z less than or equal to 0.75 root n by 2, right. You can split the area. So minus 0.75 root n by 2 to 0 first area plus second area 0 to plus 0.75 root n by 2. So because normal curve is symmetric, therefore the negative area which is equal to the positive area. So we are having 2 times, right? 2 times probability of 0 less than or equal to z less than or equal to 0.75 by 2 root n is equal to 0.95. So that is equal to probability of 0 less than or equal to z less than or equal to 0.75 root n by 2, which is equal to 0.95 by 2, that is equal to 0.475. So from the table 0.475 is exactly equal to 1.96 from the normal table. So 0.75 root n by 2, which is equal to 1.96. So you will get root n, which is equal to 1.96 into 2 by 0.75, that is equal to 5.2267. Squaring both sides, n is equal to 5.2267 the whole square. So it is equal to 27.318. So 27 approximately, not 21. So typo error. So approximately 27. So sample size is 27. Next problem. An economist would like to estimate the mean income mu in a large city. He has decided to use the sample mean as an estimate of mu and would like to ensure that the error in estimation is not more than ₹100 with the probability 0.90. How large a sample should be taken if the standard deviation is known to be ₹1000, right? So given population standard deviation, last line, sigma is equal to 1000, and error, right? Estimation, not error in estimation not more than ₹100. So error E is equal to 100, right? To find the sample size n, we know the formula. N is equal to Z alpha square, because error is given, so we are using that formula directly. Z alpha square sigma square by E square. So 90%, here you have to take probability with the probability 0.90, right? They have given. So 90%, the value of Z is 1.645, right? So note that. So we are using that n is equal to 1.645 square, 1000 square by 100 square. So 270.6025, approximately 271 sample size. Thanks.